Hi everybody, welcome to part 2. You know, this week has been a lot better. Last week was really busy. We were out of town, had a whole group of us. We had a big installation that we did, and a lot of driving and a lot of working and a lot of late hours, and it's kind of nice this week having a little bit of at-home time. So before we get started on part 2, I want to mention a couple things here that I found. And the first one was this little shield. It's facing the opposite direction right now. I see this there's like a little foam pad that goes against the transformer, and it's supposed to prevent it from vibrating against the transformer. And this is just a shield from the tuner assembly. But when I removed it, take a look at that. This foam actually reacted with this transformer and caused that little bit of rust there. The rest of the transformer looks brand new, so I'm going to have to clean that off. Hopefully it's just a surface thing and we'll be able to remove it. The other thing I wanted to mention, and I should have, when we recapped the control board that had the line stage, had all the tone controls and the volume knob and everything. If you noticed on that board, go back to the first video, you will see a bunch of transistors that had 5 legs on them instead of 3 legs. And what those were, and you've seen those in previous videos I've done, especially on some of the Pioneer gear, but those are transistor packs. There are 2 transistors in one case. And the whole purpose for those is they are a matched pair of transistors that are thermally coupled inside that one package. So instead of having to match 2 transistors and then glue them together like we do, you just use that one. Now the thing is, you can't find those anymore. They're really not making them. You might be able to find some new old stock or something like that, but they're not real common. And you have to make your own to replace them. So I typically, those are very low noise and very well matched, and typically I will not replace them unless they go bad. The unfortunate thing is they do go bad sometimes. So whenever you see those sorts of things, you really need to do a lot of bench testing. Leave this on the bench running for a long time to make sure you don't hear any hiss or pops or shot noise or anything like that, to make sure none of those are bad. If they are, you'll have to troubleshoot it and replace it. But I typically won't replace them unless I have to. Just thought I'd mention that. So let me clean this up, and we're going to get started on recapping. And I'm going to start with the little power supply board, because that's that's an easy one to knock out. We'll get that done, and then we'll move on to the power amp board. That's better. So I used 3 applications of this Quick Glow. This is great stuff for anybody who does restoration of any kind of metal or anything like that. This stuff, I don't know what it is, but it works so well. So I put 3 applications of that, and you can just see how much of this rusty stuff comes off. I don't know if that's rust. It's more, I think it's just more this foam, but of course the adhesive seems to be reacting with the chrome on that too. So I need to remove this as well and clean it. And then I put one final application, and I wiped it off a little bit with a rag and then kind of scrubbed it with this scouring pad. And then I put one last little coat or application of this hand cleaner. It's just a gel hand cleaner. I polished it right up. So that's good. I'm going to clean this up, and then we can put that back together. After removing the old foam, I just took some Goo Gone and removed the sticky stuff, and then just applied a new little piece of gasket material. And we're just going to put that back in, and I think we're good as new. All back together, and while I was in there, they had a piece of that foam on this one, so I removed it, cleaned it, and put a new foam on that one as well, new bumper, and everything's ready to go. Well, let's start by pulling this relay off of here so I can check it. and see what the contacts look like and everything. I might end up replacing it with a better one. I don't know. We'll see what this looks like. Who knows? I was saying, work's been really busy lately, and which is a good thing considering coming off of a slow time. And just installed a nice piece of equipment, our digital rad room, and we have a new product that just came out like a couple months ago, and pretty cutting edge technology. It's supposed to be able to use about a quarter of the X-ray exposure that a normal detector used to use to get the same image quality. So that's going to be really great, reducing the exposure to the patient of radiation. And so far, from what we're seeing, it is pretty good, and the image quality is excellent. So I'm pretty happy with that. But I'd like to do more videos on what I do for a living, but as you can imagine, manufacturers of that type of patented equipment are very, very protective of their trade secrets and things, and they really don't appreciate their equipment, you know, kind of being dissected online, shown to the competition. So I have to kind of watch what I can and can't do and say about my job. It's exciting, some of the technology that's out there. It's pretty amazing how much the medical imaging industry has evolved over the years. But it's also a shame that I can't show it to everyone. I mean, we could talk about it, but can't always show it. Let me get this relay out of the case here, and then we'll be right back. Okay, let's see if we can do this around the camera without destroying it. Doesn't matter, I have another one that we could replace it with. But if it's in really nice shape, I'm just going to leave it alone. I just want to see where we're at with it right now, or where we are. So there's your contacts. And you can see they're a little bit tarnished, but it doesn't look like the silver plating is off of them. And it looks like we could probably clean them. So let's try first, and then we'll see. If they clean up and polish, then we'll leave them alone. If not, we'll put a new relay in. Okay, so here is a chemical that we use a lot at work. It's called Electromotive. It's by CRC Chemicals, and I'm sure there are other people that make, or other companies that make this. This can be sprayed directly on energized equipment, as you can see. It removes everything. But you have to watch. It is really strong. First of all, the smell is terrible. It will really bother your sinuses. Number two, it eats certain types of plastics and things. It's very strong stuff. And the important thing about it is it doesn't leave any residue whatsoever. When you do a contact on a relay, you never want to use any type of chemical like deoxit or anything like that that's going to leave behind any type of protectant. That's really, really bad for relay contacts. They need to make solid contact. They cannot have any kind of chemical or residue on them, or it will cause them to arc and it'll carbon up the contacts and ruin them, and the relay won't last. So cleaning them is, you have to make sure whatever you do, you leave no residue. Now there is a little tool that I can't find. I have one. It's called a burnishing tool, and it is kind of like a real fine file. It's very super fine for polishing these contacts. I don't recommend that on these types of relays because the coating on them is so thin usually, and it tends to not leave a good enough finish, and it wears off the plating on the contacts on a lot of these relays. So I don't use burnishing tools. I clean it with this Electromotive. If it doesn't work, I put a new relay in. I don't mess around with it. So we're going to just spray a little bit of this on there, like so. And then we're going to just use a cotton swab to clean it off. Yeah, this stuff stinks, but you can see it just polishes it right off. See that? You can try alcohol, denatured, or I mean anhydrous isopropyl alcohol, but you'll find out none of that stuff will work. Only this seems to work, and it leaves them pretty clean. So you just have to be patient and clean it off. And if they polish up and it doesn't look like you've worn through the plating, some of these are solid and they don't have plating on them, which is good. But this will make sure everything looks good. And again, if they look pitted or anything, I don't try to sand off the pitting or anything. I just replace it for what these cost. I'm doing this so that you can see some of these relays are hard to find on certain stereos, so you have to clean them. You really can't replace them easily without modifying the board or something. So I wanted to show you this regardless of whether I replace it or put it back in. I just kind of want to show you the process here. Alright, let me finish a couple more coats of this stuff. We'll clean it up, and once I do, I'll come back and I'll show you what it looks like. And if they're still good when you're done, it should look like this. Now to get into these ones here, I just use a pipe cleaner. Let me back out a little bit. And you have to use a real pipe cleaner designed for cleaning pipes, like a smoking pipe. The reason I say that is you can buy these pipe cleaners in a craft store, and the ones that you buy for a craft store do not have the solid cotton in them. They are made out of cheap, like a nylon or a cheap type of material, and it falls off. It doesn't have the same thickness or consistency of an actual pipe cleaner, even though they're a lot less expensive. So make sure you get ones that are actually made for cleaning a pipe. If you do, you can get in there, and I soak it with the CRC, and then I just go right in like this. I'm working around a camera here, and you can see you just buff them right off. And then when you're done, use the other side, the dry side, to polish and dry it a little bit, and then blow off the dust, and they're all set to go. So now we can reassemble this like so. And we should be ready to put the little spring back on, which I'll do that off camera because it's kind of fidgety. And this relay is good. It's like brand new, so it's not going to need to be replaced. Again, that's the only way I would clean one of these. I do not use any kind of thing that will scratch or anything like that. I don't use burnishing tools. I don't use real fine grit, 2000 grit sandpaper, nothing like that. You can do that on contactors. Let me show you the difference. This is a relay, this is a contactor. And don't confuse the two because they are different. They both do the same thing. They switch. They switch whatever voltage or signal, through them. But understand, a contactor is different. And if you look inside here, let me pull one out for you so you could see a contact. So these are what the contacts look like on a contactor. See how flat they are? And they are specifically designed to draw an arc when they pull in and out. And they also, you see these springs in here, when they come in, hold on, let me get this back together. Okay, just had to move it over here to be able to pop that in. So you can see when these come down like this, they actually will move. They can actually shift a little bit back and forth and rock. And that whole rocking action and so forth allows the contacts to self-clean. So they kind of replenish themselves. And it uses the high current that these are designed to carry to keep them clean. They can last a very long time before they'll get all pitted and ruined. And these ones you can clean. You can actually take these off. Let me take one off here. And you can burnish them with a burnishing tool. Or, had one here a second ago, you can use a scratch brush and just kind of polish them off. And you can see the contact material is not plated on these. It's solid. There's no plating on these. It's the same material the whole way through. You can see the contact material is fused onto the conductor. And that really thick piece of, I mean, that's what, over a millimeter, almost a millimeter, 1.5 millimeters or so. And that can wear all the way down. It's designed to do that. And it's not like a plated contact in some of the smaller relays. Now, some of these relays have solid contacts like that as well, and they're better quality, but not all of them. Now, just on a side note, what do we use this for at work? Well, the high voltage cables where the connect to the X-ray tube, they can carry up to 75 kilovolts or 75,000 volts. You can imagine they do arc from time to time, the connectors. And the connector for an X-ray tube is like a well with the pins down inside, and they're probably about that long or so. And when those draw an arc, that arc will actually, it'll burn the vapor proofing compound that we put in there to insulate it, and it'll turn it into carbon, and you'll get these carbon tracks, and they're very hard to get out of the plastic material that the connectors and the wells are made of. This stuff cleans it right off instantly, and it leaves absolutely no residue whatsoever. You have to watch other cleaning products that even leave the slightest amount of residue. They'll actually produce a path for that high voltage to arc, and it'll just completely destroy your X-ray tube or your cable end, which is very expensive. So this stuff works really well for that. It removes all of the vapor proofing compound, it removes all of the carbon tracks, it cleans everything and leaves no residue, so that you can re-insulate it, re-grease the cables and put them back in. So that's what we use this stuff for. Okay, we're going to just test our relay to make sure we cleaned it properly and then we reassembled it properly. And we can even put the cover back on. Let me do that. And that little piece broke because it was kind of brittle. The rest of them are good. Okay, so the first thing we're going to do is we're going to go up, and what I'm going to do is this is connected to a power supply, and you can see we can pull the contacts in and drop them out. So we're just going to simulate, and we're going to look up at the meter, and I actually have the Kelvin connector so we can see kind of pretty accurate resistance of the contacts. We want them as close to 0 ohms as possible. So if we shorted the leads together, we have 0 ohms. You see that? So now we're going to connect with the first contact, and you can see we have an open circuit, and when we close it, and right there it is 0.035 ohms. So it's 35 or 34 milliohms. That's very good for one of these. So now let's move up to the next contact. We want to check all 4 of them like this. So here's the second contact. And it's even better. All right, let's go to the third contact. And I'm not on it, am I? There we go. Oh, that one's not reading anything, is it? There we go. I wasn't clipped on it properly, and you can see that one's really low. And then the last one. Perfect. So you can see those contacts are excellent. Remember, any resistance that's in those contacts is going to add to the resistance of your speaker load. And it can affect your damping factor. It can affect the amount of current getting out to the speakers. Anything like that. And remember, any amount of resistance will be converted into heat. And as the contacts heat up, when you're playing loud music, it'll get worse. The resistance will get even higher. But this is 15 thousandths of 1 ohm. So that's pretty normal. I mean, just the making of the contact of the probes to the actual contacts of the relay will have that much resistance. So those contacts are very, very low resistance. Okay, let's put this back into its happy little home, huh? See if we can do this around the camera, huh? Okay. Rather than this, I'll use this stuff. And, you know, I've learned over the years, working with other people and owning a business, having employees and things, you learn not to be a my way or the highway kind of person. In other words, these things I show you in here, I don't believe they're the only or maybe even the best way to do things. It's how I do it, and I'll share it with all of you. But others may have their own way of doing things, and if it achieves the same or better results, that's fine. Being open to different things like that is important if you're going to learn in electronics, because there's so much involved in electronics and there's so much history behind it that people often forget that there were other ways of doing things in the past, or maybe even new ways today, you know, of doing something. And it's good to learn. And the only way you learn is by opening your mind to other techniques. So I always tell my employees, you know, here's how I've learned to do it, or how I've become comfortable doing it. But if you have a better way of achieving the same goal and getting as good at or better results, I'm all for it. You know, when you hire people in this industry, they're smart people. You have to be to do this sort of stuff. And to me, hiring someone that's intelligent and talented and has put a lot of effort into learning this career, and then to tell them how to do their job, I don't do that. I don't believe in that. I appreciate all the talent that everybody brings to the table when they come to work and when they come into this industry. That's how we learn, and that's how we get better. All right, look at that. So where's our little alcohol brush? We have a little bit of I keep saying denatured. This is that anhydrous isopropyl. And if I can find the little brush that I was using, it was here. Stand by. Much like Monty Python's parrot, the brush is no more.
This parrot is no more.
So I have switched to this alternate brush so I can clean the flux off of the board. Some of you might know what I'm referring to. Some of you might not, but then that'll give you something to look for. More entertainment, huh? All right, that's all done. So let's start replacing these capacitors. We'll pull these big ones first. Get them out of the way. And while we're at it, we're going to try to clean the board around it as we pull the caps out. So let's give ourselves a little more breathing room here so we can rotate this. And I have to wait for my desoldering gun to heat back up. It went to sleep. Okay, we're all heated back up. It doesn't feel like there's a whole bunch of glue on there, which is a good thing. Although I do feel some glue. Yeah, there's a little bit. Okay, what is this? 470 microfarads at 63 volts. Let's see if we can find one. While we're in there, we'll take the time to kind of brush the dust out. And this does have some glue on it, but it doesn't look to be in any place where it's contacting any metal or traces or anything like that. There's one little place. Let's see if we can zoom in so you can see it. I don't know if you can see it from here, but looking down, this camera can only go so far and stay in focus. Can I show you? Yeah, see it? See how it's all green? And that's the only place where the glue actually came in contact with a lead, and you can see what that glue does to it. So we'll have to replace that. Okay, to neutralize that green stuff on a board, I take some vinegar, just some plain white vinegar on a cotton swab, and I just clean it off, and you can see just all comes off on there, and it also helps soften up that glue. Then we can take a little scraper of some sort, and we can get the glue out of that area so that it's not coming in contact with any wires anymore. And that really helps. But I know a couple people asked, why do you have a little container of vinegar on your bench? Well, besides being able to dress your salad, it also really works well on this kind of stuff. Better than alcohol. And you can see how it's kind of softens some of the glues, not all the glues, but certain, like this one really breaks down when you put vinegar on it. Makes it easy to clean. So you can see, there we go. Cleaned it right up. A little bit, there it is. Good as new. All right, let's put a couple of .01s in there if I can find them. Well, let's see if our vinegar can get this glue off. Look at that. That's pretty bad. Try to get it soaked in there good. Okay. Let's see what kind of luck we have now around the camera. Might need a couple of applications of it. It is breaking off though now. It's coming loose. Yep, let's put a little bit more on. Nice. Now, I've really not found any easier way to do this glue because it just, you know, sticks to the board. You just kind of have to soften it up as much as you can and then scrape at it until it's gone. And then clean the board off to get all the little pieces out when you're finished. Okay, that's good. I don't think there's anything that's going to contact anything there. Now I'll take a little bit of alcohol and just kind of clean it off a little bit where all that stuff fell off and everything. All right, and we have our new 330 microfarad capacitor at 63 volts. And we shall put it in like so. And I don't even know if I'm still on the camera. I'm probably not. There, now I am. Okay, snippy, snippy. Move my elbow in front of the camera and tack it in. Okay. Okay. There we go. So now we'll clean up all these ones around here, and then we'll work our way down to the bottom. Okay, so I replaced all the capacitors on this board, and we have the relay mounted back up after it's been cleaned and tested. And now I'm focusing on this one power supply transistor. We want to make sure, A, that it's okay, that it's not been heat stressed or anything like that, and B, we want to replace the thermal compound on it. And I've given this talk many times in other videos, but I kind of sometimes reiterate some things because not everybody watches every video that I have. So let's do a quick talk about heatsink compound while we clean this up. Now we're going to use a basic silicone-based heatsink compound. This is the most common type that you'll see, and there's many different manufacturers. It's all the same formula for the most part. It's that white colored silicone paste, and you'll see it here in a second. Now I've done multiple videos on this, and I like to go over this, you know, for those who don't watch all my videos. But be aware, back when these devices were made, it wasn't a big deal. Heatsink compound was, you know, there was only a few different types that they used, and they were all suitable for this. But today, with the advent of modern computers, you know, personal computers, especially the ones that have the high-powered microprocessors, you know, we hear about the Core i7 or the, you know, whatever, Pentium and all these words. Microprocessors also have heat sinks on them, and they can produce a lot of heat. Some of them will produce up to, you know, some of them are rated at like 195 watts of heat dissipation. That's a lot of heat. And the heat sinks that they're connected to have to be able to quickly dissipate the heat from the chip, because the chip makes very rapid changes in temperature as the clock speed and the cores activate and deactivate and go up and down, because processors will throttle up and down as, you know, as the processing power is needed or not needed. And because of that, you have very rapid temperature changes. That's why if you power up a computer and you don't have the heat sink on the processor, it will very quickly damage the processor. And there's things called electromigration and other things that take place, and I'm not going to talk about all that now. But the idea is you need very good thermal contact between the heat sink and the microprocessor. Because of that, they've developed some very high-tech types of, and sometimes expensive types of heatsink compound. And you might think, well, it's better heatsink compound, so maybe I'm going to use that on my stereo. And I'm going to say you do not want to do that. And the reason being is a lot of the modern types of heatsink compounds designed for computers, and specifically for microprocessors that get very high temperature, they contain metals such as copper, silver, some of them even have gold, and the compound itself is actually electrically conductive. There's two types of conductivity that we're concerned with heatsink grease. Thermal conductivity, which is its ability to conduct heat, how quickly it can and efficiently, But there's also electrical conductivity, much in the way that a wire conducts electricity. This type of compound is not electrically conductive. In other words, it's an electrical insulator, but it is a thermal conductor. Very important to differentiate between the two. Whereas some of the more exotic heatsink compounds that are out there that contain silver and so forth, not all of them, are both thermally conductive and electrically conductive. Now, it's not because they have to conduct electricity, but it's because of the compound that's in it. The byproduct of that is that it becomes electrically conductive. On a heatsink for a microprocessor, that doesn't matter, because the case of the microprocessor isn't connected to any electrical element. So therefore, when you connect the case to the metal heatsink and the metal heatsink to the chassis ground or the common point, it doesn't matter because there's no electrical connection to begin with. However, I have this transistor flipped on its back, or it's on its front for a reason. If you look, this is a metal tab, and this metal tab is actually electrically connected to this center conductor. And the center conductor is actually the collector of the transistor. It's actually one of the elements of the transistor. So if we bring in our meter here and we turn it on to ohms, if I touch this metal tab here around the camera, and I touch the center contact, the center lead, it's a dead short because they're connected together. So the reason that's important is anything that this metal part here is touching is also going to be connected to your collector. And if we go back to our schematic, and I'll find it real quick for you. Here it is. Your collector is connected to a voltage, 26.2 volts or 40.2, depending on how you want to look at it. But anyway, there's voltage there. So if this metal heatsink is touching the chassis or is touching another component, and then this center tab is touching the heatsink, then you're connecting that heatsink to 26 volts and possibly shorting it out. Now, in the event that you have that, you'll see those either mica or silicon pads that will actually, or silicone pads that actually electrically isolate or insulate the electrical connection between this and this. So it will allow thermal conductance, but it will insulate against electrical conductance. And that's why you'll see those pads, either the mica pad or the sil pads, and then there'll even be a little fiber washer that fits inside there, and the screw goes through the middle of that washer, so not even the screw will touch the tab or and connect it to the heatsink. Now, anytime you have an insulated, electrically isolated heatsink like that, if you use that conductive grease that has the silver or whatever in it, and that grease, you get a little blob of it on the side when it squishes out, you will actually make an electrical connection between the heatsink and the transistor's collector. Same thing applies to those big output transistors in the amplifier section. So you never want to use conductive thermal compound, electrically conductive, on this vintage gear. Okay, so that's the purpose of this long talk about it. And I know some of you have heard this 2 or 3 times that watch other videos of mine, but those of you who do not, be aware that that is a possibility, and you can actually introduce problems into your receiver when you restore it by doing that. So keep that in mind. So we're going to put a little coating of grease. This is not electrically touching anything. So if you notice, they did not have an isolating or electrical isolation pad. There's no sill pad, no mica pad. It's just directly connected. And the purpose of this heatsink grease is to fill in the tiny little microscopic voids of the transistor's metal case with this aluminum case. Now, the really exotic heat sinks and so forth will be highly mirror polished to to make the best surface contact possible. And you just don't see that in these. So this kind of fills in those little microscopic voids and gives you a better thermal connection between this and this. That's why we're going to put that on. Just put a little bit of this on. And again, those of you who, seen all this and heard of it before, feel free to skip through because I get it. All right. So when we put this on like this, on a large surface area like the big TO3 transistors, I'll actually take a little brush or a little, spatula or something, and I'll spread the grease more evenly. But these little ones, you could just put a dollop on there like that, move it around, and it'll kind of spread it in there, and you'll be all set. And put the screw in, and we'll tighten it back up. Now this heatsink I like because you'll find out when you start tightening this, when the screw head grabs the tab, it'll want to rotate this thing. But if you notice, this has that little bump there, and that prevents the transistor from spinning off to the side when you tighten it. If not, you're going to have to hold it with pliers or something. See how nice that is? And then you just kind of snug it up. And you see how that heatsink compound squished out there? Even if you had an insulator in there, if that grease were conductive, it would be connecting this tab to this heatsink. And that's why you would not want to use that real exotic heatsink compound, even though it's a little better thermally conductive. Remember, this thing lasted 40 years with the old style grease, and it never overheated. So you don't really need that. Put in there what it had. It worked. If there was a problem, it would have happened early on with all of these units when they were produced. And of course, then we would have to come up with a different solution. But in this instance, putting the same in will be just fine. Okay, all set to go. So let's mount this back in there, and that board will be done. Board's all put back together. It's cleaned, and it's reinserted, ready to go. And it is early morning, and I have to go off to work today. So I'm going to end this video right here so I can get something posted. And when we come back, our next part, we will do a little solder and talk video as we restore the amplifier modules. We'll talk about some of the parts on here and some of the choices we make, and we'll go from there. So until then, I wish you all peace, joy, happiness, and good health in your lives. And I hope all is well with all of you, and I thank you all for the emails and for all of the well wishes and so forth. And we'll see you again real soon. Take care. Bye-bye.